So hi everyone. I hope you all had a good day so far and a good lunch. As Isabella said, my name's Ralph Scott and I'm a postdoctoral researcher at both Cardiff. I'm in that kind of period after your doctorate where you're working multiple jobs. But today I'm mostly going to be talking about work that relates to the British election study. And I'm going to talk to you about a potential kind of social research use for large language generative models such as that underpinning ChatGPT, which you might have heard of. It doesn't matter if you haven't, I'm going to explain what it is. Encoding open text survey responses. This is based on a working paper which is currently under review with colleagues on the British election study. I've named them on the front slide here. Where we test this potential using our own data, and again, I'll talk about that briefly. So just firstly, to kind of describe what I'm going to cover, I'm going to speak for about 30 minutes, in which time I'm going to set out the research problem. I'm then going to provide an overview of ChatGPT and kind of, I guess, LLMs and how they work. I come from a social research background, so I'm not going to get kind of deep into the computer science, although I can refer you to some things that might help if you're interested in those questions. I'm then going to describe basically, in a nutshell, what we do in the study as a kind of a test case for this approach. And then I'm going to talk through some of the potential and the issues, because it's not without its pitfalls, both kind of practically and in terms of like future thinking about kind of research, I guess like ethics or questions along those lines in the future, and then we'll have 10 minutes of Q&A at the end. So as a kind of caveat, just to say that we approach this as kind of social scientists rather than computer scientists. And just to say that we're very aware of the kind of potential challenges and biases that there might be in these models as well. It's something that we're thinking about, but keen to kind of discuss that in the Q&A when it comes to it. I think mostly we're seeing this as a practical guide that you can hopefully use in your own work in doing this kind of work. So I know that 30 minutes is a fairly long time to listen to anyone, so I'm going to provide a kind of a summary at the very beginning, just to give you an overview of what we find and then go into the detail. So what we find is that these kind of state-of-the-art LLMs, and just this week we've been testing, you might have seen that the company behind ChatGPT released a new version of the model about 3 months ago, so we've been testing if it works better, and it does. These models seem to just keep getting better at this job of kind of interpreting and then producing text. But it does seem, depending on the nature of the test that we give it, it does seem capable of replicating human-level performance in terms of coding open text data. So GPT 3.5, which is what we tested in the paper as it currently is able to match the human coder, the original human coder's category 95% of the time, which is similar to kind of human performance. The main thing that I think is really impressive about this is you don't have to, if anyone here is familiar with kind of machine learning approaches or approaches where you kind of do supervised learning or you train a model to do this kind of coding, that training can be quite intensive. It can take quite a long time, and that, depending on how much computation you have to play with, that can be quite limiting. You don't really have to train these models. I'll talk about what examples we gave, and you'll see, I mean, I think that's the thing that's most remarkable about this, to be honest. And then where it was wrong, it's wrong, I mean, I don't want to veer too much in this direction, but it's wrong in the way that another human might be wrong. So you can kind of see the edge cases and go, okay, I can see what you were thinking when you coded this as this category rather than the category that the original human shows. So there's one example where we almost kind of learn from the model in rethinking our coding schema. But again, I'll talk about that. But it's also worth saying that when we made the task more difficult, the model wasn't as good as a human. You know, we don't have to worry. There is still a role for humans in doing this kind of research. But the models are getting better. So the research problem. Hopefully everyone here is familiar with survey research and open text responses within surveys. They offer certain advantages over kind of closed responses. So one is that they don't prime responses to give particular answers. So you can kind of, the respondent is a bit more open to give whatever answer they want in line with the question. You're not kind of giving them a closed list of options or just giving them a statement and asking them to agree or disagree with that statement. They have a much kind of more open field to play with where they can say whatever they want, really. And I'll give some examples of the kinds of things people say in the question that we ask. But they have quite a significant drawback, which is if you've ever coded data like this, it takes a very long time. Particularly, obviously, the more data you have, the longer it takes. And you can't really analyze it without doing that coding. So that's the main reason why we don't only ask open survey responses. It's much easier to analyze something on a kind of closed, at scale. It would be better if we could automate this process, because it would save a lot of time, and it would mean we could spend more time on the research design, on the interpretation, on the kind of more creative aspects of research, basically. And that's what we do with all of the tech. I'm more of a quant researcher. All of the technology we use, we're kind of saving time so as to spend more time on the more creative, possibly interesting aspects of research. So let's talk about the British election study. If you're not familiar with it, it's one of the longest running election studies worldwide. I think probably the only longer running is the one in the US, the ANES. And it's the longest running social science survey in the UK by the definition that we use anyway. Surveys have taken place immediately after every general election since 1964. So it goes all the way back to 1964. The studies have kind of taken different forms. And one in the current iteration of the study, we're doing this ongoing internet panel. So there are these random probability samples after every election, but we're also doing this long-running panel, drawing from the YouGov panel, about 30,000 respondents every wave, and we're up to about 25 waves. We are up to 25 waves so far. And so it's not a panel where every respondent responds. It's not like Understanding Society where every respondent responds to every panel, but we do give people an invitation to kind of rejoin every time, basically. So there's a lot of data, and in each wave we ask the following question. As far as you're concerned, what's the single most important issue facing the country at the present time? So it's this kind of quite open question called the most important issue question, and they can write anything they want. So the approach we've taken so far, so this question, it's disputed, like lots of things in political science, but people think this is a useful question to ask in terms of understanding what people think matters in terms of politics. And so far, the approach we've taken, and I've done a good chunk of this myself, is to code each of the responses that we get to a range of 50 possible categories, which are then collapsed into 13 categories. So this manual labeling, we've labeled over kind of 657,000 responses so far since 2014. And if we can automate this, as I say, it frees up time, basically. Just to give you a sense of the categories, we won't kind of dwell on this, but the right-hand side of each of these columns, these two, are the 50 categories, and you can see they can be grouped into things like the economy, health. We also had to develop the schema a little bit as we went, because in the case study we use here, COVID was by far the biggest issue, and obviously we didn't have a code for COVID at the beginning of the study because we didn't anticipate it in 2014. So there's been a bit of development, but this is the codes that humans are working with, and the AI is working with, essentially. And this is what just a very small sample of the raw data looks like. So it's monotonous, but also sometimes very entertaining work when you're going through coding it. So the column A is the participant ID, column B is the wave. This is wave 24, which I think was May last year. Yeah, I think that's right. And this is kind of very near the top of the alphabet. And we just sorted it in that way. And you can see the codes we've given this. So, when people are lambasting the government, but they're not talking specifically about any party, we use this code called polneg, just kind of generally negative about politics. There's lots of things where they're talking about the strikes. We coded that as kind of just general economy because we didn't have something specific on industrial action. So there's all sorts of things. People put all sorts of crazy things in there, as well as stuff being very some things being very kind of predictable, I guess, in terms of what you'd expect people to say. So ChatGPT, let's talk about that briefly. This is a kind of a public-facing large language model that was released by a company called OpenAI last year, towards the end of November last year. Since then, it's had the fastest growing, you might have seen all these kind of headlines about it, the fastest growing user base in internet history. So that's kind of faster than the user base of Facebook or Google or any of these other things that are very familiar and have kind of been fully integrated into people's lives, more or less. The underlying model currently that ChatGPT uses is called GPT 3.5. And this has gone through, to kind of make the thing that you see in ChatGPT, it's gone through this process of fine-tuning whereby humans have kind of trained it, basically. It's gone, there's more detail in this paper, I won't dwell on it, but basically it goes through this process of kind of training. And these large language models generally are, essentially, they're trained on a huge corpus of data. So all of the text ever published on the internet is like a big part of its data, but that's not only. There's also a huge corpus of books, basically all the books that have been digitized, it trains it on that. So it's an extraordinary amount of raw text, kind of natural language that these models are trained on. And they're also given a huge amount of time and computational power to develop relationships. And they use that to basically predict the words or subword or characters that are likely to come next in terms of user prompt. So they're very good at predicting language, basically. And on that basis, they use that to then form language. So form sentences, paragraphs, and write in certain styles, because they've seen all these styles in their kind of training data. And for this reason, it requires very little in-context training when you're actually giving it a task. When you ask it to do something, it's got this reserve of information to draw on to go, okay, so this is how I might do this. And it's constantly developing. As I said, GPT-4 has just been released. These aren't the only versions of these models. There are other ones, and I'll talk a bit about those towards the end as well. But let's have an example of how it might work. So you can ask GPT to write some original poetry. You might, if you've played around with GPT, you can do all of these different things and kind of mess around for ages playing with it, as well as using it for serious social research. So if we ask it to do, so you give it a prompt. And the prompt is, write a 3-line poem about Margaret Atwood eating a canary. So Margaret Atwood, if you don't know her, she's a kind of Canadian author who does sci-fi and then other things as well. And then it can come up with a novel response that's never appeared in its training data. If you Google this poem doesn't exist, as far as I'm aware, anywhere on the internet. It's kind of developed this itself. Margaret Atwood dines with a canary on her plate, a fleeting feathered feast. And I think what's particularly interesting is you've got a bit of, I'm not a literary, I'm not like a literary scholar, but you've got this alliteration at the bottom, which again, I don't think that phrase has ever been written before. So it's kind of done this logic about what a poem might look like on the basis of poems it's seen. Yeah. So anyway, that's an example of how ChatGPT works, basically. It's very easy to misuse. I mean, obviously, there's lots of examples of malicious misuse in terms of people using it to write essays when they should be writing the essays themselves and so on. There's lots of that going on. There's also kind of ways in which you can misuse it non-maliciously, just like misunderstanding what it's good at and what it's not good at. So it's only trained on, at least when we were running these models, it was only trained on data up to September 2021, because these data sets are so large, they're only periodically updated. So it doesn't know about things that have happened since September 2021. Although there's lots of speculation about, these models aren't that open, so people speculate about where that actual line is drawn. It's also prone to hallucination, and this is the example that I've given here, where it does this very weird thing when you ask it to write, say you ask it to write a literature review. I'm not saying you should do this, and this is why. Because it's not connected to the internet, it creates a list of very plausible sounding references which are totally made up. So there are researchers who have worked on the issue, the titles sound about right. Like, it's very weird where it's doing this kind of, it's creating a kind of like alternative universe where this research has happened, but it's not real. And this lawyer in the US got into trouble for doing the same thing. Basically, it asked it to write some pre-trial documents, and it cited cases that didn't exist. And the judge was kind of looking at it and going, this is just total nonsense, why have you submitted this? So yeah, be careful how you use ChatGPT, particularly in a kind of professional setting, I guess, is the lesson. So the approach, the kind of specific approach, the methods basically for this study is we take the over 80,000 open text responses that were given to the MII question in waves 21 to 23 of the BES panel. So that's May 2021 to May 2022. And these have already been hand-coded by a research assistant, so we have a kind of correct answer. Basically, the first human that coded these is the baseline that we're using in all of these evaluation. We assess accuracy across 2 different samples, and we keep these samples consistent across all the coders that we evaluate. So the first is just totally randomly sampled open responses, but because there's a lot of repetition, we also use 1,000 randomly sampled unique open responses. This latter should be a kind of harder test because it overrepresents rare and idiosyncratic responses. So for example, of these 80,000, about 10,000 just gave the word COVID. So that's very easy to code for a human and very easy for a machine to code, because you can just say, okay, I'm going to put all of these under the coronavirus category. And there's lots of that kind of repetition where people might just say economy, and that's easy to code. It's more when there's a long string, or they mention multiple issues, or it's misspelled or something. That's where it gets more difficult, basically, and that will be picked up in the unique sample. So we compare GPT with two possible alternatives. So one is another human. Basically, that's the kind of how much does a new human agree with the original human? And then as an approach we take, like kind of a baseline supervised learning approach using support vector machines, or SVM. The human, we recruited another public opinion specialist, so someone who's a PhD student at the University of Manchester working in politics, and is a co-author on the paper as well, who received an hour of training with examples drawn from a separate sample. So we didn't give them they didn't kind of have sight of the sample they were going to be coding, and with feedback from an experienced coder on a kind of first batch of codes they did, basically. The SVM, we did two versions of this, basically, and they kind of represent different use cases, I think. So one SVM was fit to 1,000 randomly sampled responses, and this is where basically a researcher labels a moderate sample of the training data and then gives the SVM the rest to do. So the benefit, I mean, that's probably a more realistic use case if you're trying to do something quickly. Basically, you're trying to automate something. But we also did a kind of a harder test, basically, a tougher comparison, where we gave it all of the data from waves 1 to 20, all of the coded data to learn from, basically, and say, okay, if it looks like this, then, and it's given that code, then that's probably the best fit. The downside is then it didn't have data from the most recent wave, so some of it was out of context. But we think it's a realistic case where you might have a lot of coded data, but you kind of feed it forwards to the next wave that you then get. That might be an example of when you would use this kind of SVM approach. I should say that we're currently in the process of building up our alternative supervised learning approaches as well. So if people have got ideas on things we should try there, I'd be open to hearing them, definitely. As a kind of fair comparison, basically, to the GPT approach. So you might have heard about this idea of prompting, or the prompt engine, like basically the importance of how you write the prompt when it comes to interacting with models like this. It's fine, like it's just something that people talk about a lot, maybe just because I've been reading less about this, it's fine. So it's really important how you construct the prompt. I'm going to talk that through step by step, and it's there in the paper in more detail as well. So I guess the first thing to say is, if you're accessing models like, well, specifically the GPT 3.5, you access that via an API and you pay money in order to do so. So you are paying OpenAI for access to do this in a way that's kind of more systematic. But ChatGPT remains free, so we use that to experiment, because then we're not paying however many pennies it was per experiment, basically. So we start the prompt by saying, just kind of introducing the task, basically. Here are some open-ended responses from the British selection study to the question. Please assign one of the following categories to each open-ended text response, returning the original response in the most relevant numeric code. And then we listed the possible categories, as I've shown before. It wasn't exactly like that, because you can't really put tables into the, but it's kind of like this. And then we found that you could conversationally correct the AI, so as it was coding things, you could go, actually, I'm not sure about that one. So you put it through in batches of 50, and then you check them, and you say, I'm not sure about that. So you could do this kind of reinforcement approach, but if we preempted that, it actually worked really well, and then we could do it all with one prompt, basically, at the beginning. So that's what we found. So if we gave it a bit more detail, so on poll neg, if we said complaints about politics, the system, the media, corruption, and specifically where there's no politician or party mentioned, and then with Europe, we had to specify that we wanted Brexit included there, because we have a code around the constitution. You could potentially put Brexit there. So just kind of specifying what you should say. And then we had to give it a bit of information about recent kind of geopolitical developments, because it obviously didn't know that Russia had invaded Ukraine. So any mentions to Russia or Ukraine or Putin or things along those lines, we only said Ukraine and Russia, should be coded as war, basically. We then provided two examples of the response format. So this is all in the, I've kind of broken up the prompt, but this is all in the first thing we send GPT, I should say. We say, code these cases about economy or immigration, and then it comes back, this is what, we said, we want to see this, about economy, or, with economy general or immigration. And then we gave it one more example where we corrected an error that was made in testing, where GPT had this tendency, when we kept telling it not to do this, but it had this tendency to return 2 codes when someone had mentioned 2 things, basically. It's kind of trying to be too helpful. And so someone says climate change and unemployment. And we had a rule within our coding that it's basically the first issue they mention, because we're only allowed to use one code. It's the assumption that the first issue they mention is probably the thing that matters most to them. It might not be true, but that's the approach we take to the coding. So we said, this is what you sent us before, please only send us environment as a response to this. Don't keep sending us environment and unemployment. And that did address it most of the time, although there were still occasionally double codes that came through. So we then finished by saying code these cases, and then we gave it 50 at a time. And we input all of this via R using OpenAI's API. So it's something that it takes a little bit of setup, but it's not the alternative in terms of like training your own model is a lot more resource and kind of experience intensive, I think. This is relatively straightforward. And then we did experiment with doing different batch sizes and different response formats, but we found that this balanced efficiency and performance best. So let's move on to the results. Let's present those. So on this figure, what you can see is on the left-hand side is the random sample, and on the right-hand side is the unique random sample. So that's the kind of more difficult test, basically, of the more idiosyncratic responses. And on the y-axis is the percentage agreement with the original coder. So it's basically to what extent it's described as accuracy, but it's basically to what extent was this person correct by the way we're defining correct. And this is the human, and the human does a pretty good job. So on the random sample, they get kind of 97% agreement. On the unique sample, it's a bit lower, at about 92%. But that's pretty good, particularly because these are like much tougher cases. So I think the coder can be happy with that, and we can be happy that the training's working kind of reasonably well in terms of training other humans. If we then compare it to GPT, you can see that there's really not much to choose from. I should say this is in the combined categories. It gets a lot tougher with the 50 categories. But with the overall sample for the 13 categories, there's basically nothing to choose from at all. Let's see if this works. This laser pointer, yeah. So they're almost next to each other. The confidence intervals are crossing, so there's not really much to choose from. It does GPT does perform significantly worse on the unique sample, but not so much that, it kind of depends on what you're willing to accept, what your tolerance is for inaccuracy, basically. But still, so that's about 87%, 86, I think, %. If we compare it to the most basic SVM, which is a kind of like a base level supervised learning approach, it does a lot worse, particularly with the unique sample, where it's about kind of 67% agreement. And then the more developed SVM, using kind of over 500,000 cases, again, the performance there is kind of much of a muchness, but it's worth bearing in mind you might not have 500,000 cases to train on. And the performance on the unique sample is much, much worse than the GPT performance. And I guess in the comparison, I think using this much data to train this model versus we only give GPT 3 examples, really. It works on the basis of 3 examples. All of the rest of its ability at this is coming from the model itself, coming from the kind of data and the way it's interpreted that data. So that's the thing that I think is really kind of amazing about the potential for this approach. If you need it done right, though, you probably still need a human to do it, at least at this point. Let's move on to the 50 categories. So again, everyone performs worse here. The human gets kind of 95% on the overall sample and below 90% on the unique sample. And there's a lot of potential for kind of edge cases with the 50 categories. The GPT, again, is very close to human performance on the overall sample, but the performance drops quite significantly for the unique sample. And I'll talk through where these disagreements were shortly. Again, the SVM, the kind of less well-trained SVM does pretty poorly, although it does okay on the overall sample. And interestingly, the SVM here, in terms of the point estimate, is better than GPT, but it performs worse, just marginally. That's kind of just marginally significant than GPT. But the 50 category task is a lot harder, and therefore there's a lot more errors overall, particularly from the automated approach. So I guess one lesson is, if you can use fewer categories, then do. Even the human finds it hard to code to 50 categories. So yeah, I think this should be, should be good time now, I think. So what did ChatGPT get wrong? GPT-3, what did it get wrong? The most common error was to code COVID economy when the human coded it as coronavirus. So these are some examples of where GPT thought it was COVID economy, and I think you can see why. You know, things like opening up the service sector, I think that's reasonable as a code. So it's basically how much economic subtext you're willing to infer from the text. Another common error was where GPT gave uncoded, and we coded it as coronavirus because we interpreted it. So something like pandemia or covis, it's kind of like, it's obviously like a typo, but GPT doesn't want to, it's a bit more conservative. It doesn't want to like make the assumption, because it could be hovis, maybe, who knows. So I think also because it didn't know about Omicron, because that wasn't in its training data, and we didn't tell it about Omicron, that it made a mistake there. So left it as uncoded. The final category of error, and I think this is the one where it's most interesting, is where GPT considered it to be a war response, and we coded it more generally as foreign affairs, which is the kind of category when we can't, we knew it related to foreign affairs, but we weren't confident it could go in war. But I think we were really strict about it had to say something like war or conflict or. Whereas actually we came to the decision that GPT was probably right here, and we were wrong, or at least in the way that we've learned definitely and are being a bit less strict about the boundaries of this coding. Although for this example, we still consider this to be GPT being wrong. So this is just recapping what I said at the beginning, so I'll just click through. So I think, I mean, what I've tried to show is that it's GPT-3 as it stands, when you've got a fairly straightforward open text coding task, it does as well as a human being, basically, at that coding task. When it gets more complicated, it struggles. But I think what's really impressive is the fact that it doesn't require that much training to perform this well. And so you can do it relatively simply. You play around with the prompt bit, you set it up on the API, and then you kind of set it going. And you don't have to spend a lot of time training a model to do that. It's ready to go out of the box. It's possible that this is the best case scenario because there's likely to be lots of discussion of political issues on the internet. If you've got a much more specific issue that you're dealing with, then a generalized model like this might not work as well. So that's definitely one kind of limitation. Yeah. So just to kind of recap on, just to say what extensions we're currently working on for the resubmission. So we're expanding it to a broader range of models. There are things other than those produced by OpenAI. So that Google's Bard and Palm 2 and Anthropic's Claude all appear to be able to do some version of this. So there are a range of options. Unfortunately, all of these are proprietary models, and we tried a variety of open source models, and they weren't able to do it. And the problem with that is both we don't know the closed models, the proprietary models we have to pay money for them. They're privately owned, but they're also not that transparent, and they can change at any time, kind of outside of our control, really. So that's the kind of downside of using this kind of technology. We're also trying more performance metrics, and we're experimenting with more use cases. So we spend a lot of time coding occupation data in order to get to the NSSEC categorization from open text responses. If we could give GPT all of that information and it would just do it reliably, then that would save a huge amount of time, and I think that would probably apply across lots of different research organizations. So the potential for these models, I guess the first thing to say is, as things currently stand, the models are only going to get bigger and better. There is currently kind of a hype train surrounding AI, and there's good and bad things about that. And one of the good things about it, I think, is that there's more interest and investment in it. And that means that likely these models are going to continue to kind of improve. As we see with GPT-4, that's already performing. You're taking my word for it, but we've been running that over the course of the week, and it is markedly improved on the GPT 3.5 performance. This means that we think this is exciting not just because it saves us time in a specific case, but it also opens up new research possibilities. So we can ask more open text response. That's basically the thing I think is really exciting, is we might get answers that we weren't expecting because for so long we've been restricting people to the way that we interpret things as researchers in defining our questions. And we might get a lot more. I think one of the things that's really struck me about, and is a piece of research I want to do using this, is increasing examples of responses referencing conspiracy theories and things related to that. And so I kind of want to see what's going on there. And it makes it a lot easier. The fact that you can do this cheap text coding means we don't have a specific conspiracy theory code, but we can just recode all of the data using this automated approach into conspiracy theory or non-conspiracy theory, or even break it down. The issues are that obviously the accuracy is not quite there. There's also an accessibility issue where lots of these models don't have a really accessible API. That's why we've majored on GPT here, is the API is ready to go, you can use it. Sometimes you need to run an instance of the model on your own computer, and so you need an incredibly powerful computer to do that. But I think that, again, that will improve. There's also a problem with interpretability. As I've said, the model's closed, so you can't really see what's going on, and that might mean there are biases. There's lots of concern, particularly in image generation, about kind of gender and racial bias in these models, because they're reflecting the bias that's inherent in the data, in the data that they've collected and how that's kind of been modeled. And then also the problem of just the transparency and the private ownership of these models, and whether there should be more investment in supporting open source models that are equivalent or as good in terms of performance. That's something we'd like to see, and I think it's something that an academic collaboration could hopefully achieve. Anyway, so that's everything I wanted to say. Thanks very much, and look forward to hearing your questions.